Hello, hello everyone. Here we are back from our holiday break. Let me show you the actual scene here. I hope you had a good holiday. I know I did. Except I woke up this morning and it was 10 degrees Fahrenheit outside. It had been so nice and warm. Oh well, that's just the way things go sometimes. Anyway, today we are going to be checking out Theano, which might also be pronounced Theano, depending on your opinion. Oh well, we'll figure that out when we get there. Maybe the internet will tell us. So what I know right now is that Theano is a sort of machine learning framework in many ways similar to TensorFlow. It's not put out by Google. It's an open source project. It's been around a little bit longer. I have poked at it once before, but we're going to be starting fresh, meaning I'm going to install it, which hopefully does not take this entire episode, but if it does, that is part of the fun. I will probably not be using Docker unless I have to, just because I want to experience the pain of installing something. I don't intend to compile it from source, but if that's what it ends up being, that's what I'll do. So that's all I want to start with, that it's another machine learning thing similar to TensorFlow. As I understand, you define your layers as a graph with a bunch of nodes. We'll probably go through this very similar kind of tutorial. I haven't looked at anything yet, other than to see that it does exist. Here's what I've done. I've typed in Theano to Google, and that's where I'm starting. I see it exists on PyPy. You can see these links are purple. I've clearly been here. So that's what we're going to do. Theano, hey, it looks like a regular... this is clearly compiled with Python, this page. It's available on PyPy. Let's look up, not citing, not download. The status, the build is passing, installing Theano, and tutorials. You know what? Let's look at what is Theano. Maybe that will tell me how to pronounce it. That would be really helpful. Evaluate mathematical expressions, especially ones with multi-dimensional arrays, using NumPy. Can surpass C on the CPU by many orders of magnitude by taking advantage of GPUs. I feel like that's a cheating kind of statement, because you could just write CUDA or any other, you could write code running your GPUs in a compiled language. I don't think that's a fair comparison, but I'm splitting hairs. But it makes it easy to use the GPU, so that is a real advantage. We're going to do import Theano. From Theano, import tensor. This is going to feel really familiar. We're going to define a couple values, say that C equals this, and then somewhere down here, Theano.function, that's sort of our output, and then we say, hey, do this with these inputs, A, B, and these outputs, C. And we're adding what, 1.5 to 2.5? No problem. Execute speed. What does it do and what does it do that they don't? Python library for manipulating and evaluating expressions, especially matrix values one. Yes, that's what we knew before. SymP to Mathematica, NumPy to MATLAB. That's interesting. Hybrid. They're saying Theano is a hybrid of the two. That's interesting. I guess it's symbolic in the sense that you've got some variables here that you're just throwing together and then adding them, saying, hey, compute this. We'll see. All right, that's enough of going to the overview. Let's look at installing. If you're a member of Lisa Labo, I am not a member of Lisa Labo. That's interesting. We have Python greater than 3.3. Huzzah. I believe I have G++, but highly recommended to order, compile, generated C code. Interesting. I have NumPy. I believe I have SciPy. I assume I have BLAS. If not, we're going to find out. Optional, nose. Run Theano's test seat. Not worried about that. Sphinx. That's what builds this page. Sphinx is what builds nice Python-looking pages like this. They use it's similar to Markdown. It's called restructured text. I actually learned it first, and I loved it. It was so great. And then I learned about Markdown. And I thought, oh, this is even better. So I'm a big fan of Sphinx. Py.ng. Git is of course Git. You should use Git. Py.ng. We'll make picture of Theano computation graph. So this is what I wasn't ever able to do in TensorFlow. So maybe I'll be able to do that properly in Theano. So dot. This is called py dot, but dot is a Linux or Unix command line program that can create a nice picture from a graph that you actually specify the nodes. 1 points to 2, 2 points to 3, 3 points to 1, whatever. I've used that several times for building figures on papers. NVIDIA CUDA drivers, yep, so that's good. libGPU array, interesting. That's cool. So we're on Arch Linux, but it says that it was available from PyPy. So let's see if there's pip on here. Easiest way to change the release version is from using PyPy. Pip install Theano. Let's try that. Just do the dead simplest thing. Was it really capitalized? Oh my gosh, it is. That's madness. That's crazy sauce. Who capitalizes the name of their package? Is that a thing people do? Alright, we are currently installing. I should have done that first and then continue to talk. You may need to add sudo. Yeah, I might end up having to do that. We'll see. In fact, let me go ahead and do that. There we go. All right. Now we are going well. Open live chat. I did not open the live chat. That was foolish of me. Yes, we're trying out something new this week using the YouTube event instead of the just hit the go live button. We'll see how it works. There, now I said something in the chat room. Brilliant. Alright. Things always take a little while to install. They download, you gotta pull it down, see if we actually have everything. I've got NumPy, I've got SciPy. Let's take a look and see what the tutorial is going to be. We don't need a Python tutorial. I'm familiar with NumPy. I don't need that. Algebra. I understand how to multiply matrices as I established in the last video. More examples. The logistic function. Computing more than one thing at the same time. I kind of want to see... Maybe we should. Let's look at... let's look at baby steps. We're into basics. I saw the basic TensorFlow video was pretty popular. So let's have a do with that, shall we? Alright, so we're going to add scalars. That's very simple, very straightforward. Step 1, we're going to examine the type. We're going to make a couple matrices. We're going to add those guys. It's going to be real simple. How crazy does this get? What is the most complicated thing we can do without knowing what we're doing? How nutty does this get? Multiple cores, that's important. Python memory, extending with C, so writing your own C extensions. Dealing with nans, debugging, how shape information. So this is like a true, this is interesting. This tutorial just sort of walks you through very specific individual things. Whereas the TensorFlow tutorial said, here, we're going to show you how to do MNIST with this data set. I'm sure that such a thing exists for Theano as well. Let me see. MNIST. Hey, what do you know? It's on the same webpage even. Classifying MNIST digits using logistic regression. This is exactly what... I might have even looked at this webpage when we were doing that with TensorFlow. So yes, this is that same, what I call multinomial regression, multinomial logit. They call logistic regression or the softmax function. Just a matter of what your background is, where you come from. As before, you just got this standard linear regression kind of thing. Your weights times x plus some constant. But it's e to that over the sum of e to each option you have. So each either digit you could put this thing could possibly be, or which mode of transportation, or whatever. I think in transportation this became big in like the 70s. The author's name escapes me right now who made this big, which I should really ought to remember. It was a big deal. But anyway, they have a tutorial for this. The loss function, which is for how quickly you learn, I'm guessing. Negative log likelihood. Creating the logistic regression class. Well, this is involved. Oh my. Learning the model. Testing the model. Putting it all together. So, just from glancing at this is a lot more going on than say like TensorFlow. And I mean that like it looks like the user has to do a lot more things. You probably have more direct control. But in terms of just making something like MNIST dead simple, TensorFlow is probably pretty good, it looks like. And Theano is like, well, you can definitely do it, and it's not like this is not the worst thing in the universe, certainly. But for someone new coming in, they're gonna look at this and say, there's a lot of things here. I have to define my own class. Oh. But that's why we're gonna start with the baby steps. Successfully installed Theano 7.0. Huzzah! Let me do the silly thing. Baby.py. Alright, and we are doing baby steps now. Import theano.tensorst. From Theano import function. I really don't know if I like having something called function. I guess it's alright. Go gadget Slimeux. I'm on... Yes. You can see I'm running also mixer. Apparently not on 3 panes. There we go. Let's see how that goes. Come on. Oh, look at that. Pip installed and it actually opened. Life is good. Life is good. So what's the magic here? I'm going to copy these things and then see what they do. Okay. So a tensor type object, or from the module tensor, dscalar. That's pretty neat. That we can just get that. So that's as before. Dscalar, I assume, is like double scalar. Let's take a look. What do we got? Oh, D-type. D-type string corresponds to numpy D-type, e.g. in 64. So just a data scalar, broadcastable. So, but I didn't really give it a type. I must default to something. Okay. So I guess it's not a double specifically. Z is x plus y, of course, and then we define our function. So if I said, for example, 1.5 plus 2.5, that by every right should equal 4. So if I say f of, do I pass it in like this? 1.5, whoop, see if I can type, 2.5 is an array with 4. Okay, yes, that makes sense. It returns an array. What can I do with f? Outputs. Can I change out outputs? New list initialized from intervals items. Alright, I'll have to understand that later. If that value. Alright, cool. So yes, this is just like when we played with TensorFlow. You define your graph, in this case, x, y, z. X and y are sort of the inputs, z is an intermediate value, and our final f function says, hey, compute this thing. So this is kind of interesting in that we're defining a specific function, and that's how we're getting at it. We're not defining this overall session and adding things to it. And yet here you see they add 2 and 3, they add these other numbers. They're going to break this down into even simpler steps. It is worthwhile for us to look at the type here. That is useful. So let's do that. As in, what is x? It's a tensor variable. What is z? It is also a tensor variable. Even though x is sort of our input. Let's make something a little more complicated. Shall we? W equals, what is it? Z plus y. Shall we? And I want g to equal function. And I want to say, what happens when I do z comma y? And I want to output w. This should be totally legit. Let's find out. Doesn't have a problem with it. And then logically, will it just accept Z as whatever the input is? Does it just sort of inspect W and say, all right, well, what does W need? Someone was asking a question, how to set your dev environment with Vim, Tmux, etc. Let me get back to this Theano thing in a second, but that's a question I can answer right away. I actually have a GitHub repository for just setting up my environment if you're on Arch Linux. And like, I love like building the cool workflow, so that's why I'm going to pause and look at this new thing and talk about this for just a few moments. I promise to get back to Theano shortly. So yes, I recreate my dev environment with this repository I've created called compute-tools. You can see the name of it here. It's github.com/dvbuntu/compute-tools. And if my computer weren't slowing down right now, I would be all too happy to show that to you, but it's a little locked up. Let me just type that into the chat for people. So this is basically a shell script I've whipped up that will, from a base Arch Linux install, recreate my entire development environment. I run Arch Linux, so that works really well for me. I tried making it into an Arch Linux meta package, but there was too many dependencies and too many things in the Arch user repository that it didn't work. But that works really well for me. But I'll definitely think about doing a longer form, and maybe I'll just start with an Arch Linux, and I'll essentially install my development environment, because that's something that I want to work really hard at. Also, I talk more about it linked in one of my websites. Let me just link that real quick. I talk more about my workflow and why I think it's the best thing ever. I'm working on, it's available as an ebook. I'm working on releasing that as an actual book you can buy. That's down the line. We'll see. Anyway, back to Theano. So let's see if this G function actually works. So Z is nominally x plus y. So by all rights, this should be x plus y. I want to find out, however, if it yells at me, because Z is an actual... Does it just say, oh, W depends on Z and Y, and I've given it Z and Y, and it doesn't care that Z was actually x plus y? Let's find out. 2 and 3. It's totally fine. It says you gave me Z, I didn't care what Z was before. What if I pass it in X, though? Still works. Oh, no, that doesn't. That doesn't work at all. Let me redefine G. Hang on. Yeah, that works. Because that's 2 plus 2 plus... Wait. No, that's 2 plus 3 plus 3. 1 plus 2 plus 1 plus 1. Yes. It's silliness. So yes. So this is actually pretty cool. I would not have guessed that it would work so straightforwardly. So what just happened here, for those that I moved a little too quick for, which I understand I do sometimes, we defined Z up here as to be x plus y. X and y are both sort of basic inputs. W then takes this intermediate value and adds y again, because why not? So when I had the function as x and y, and my output is W, Theano is going in and inspecting W and say, okay, I need Z and I need Y. I don't have Z. What does Z need? Z needs X and Y. Okay, I have X and I have Y. Let me compute Z, and then let me compute W, and then let me give you that. Or I can say, hey, I just need Z and Y, so let me, and if I pass in Z, it says, all right, cool, I don't care what Z is defined in as before, I'll just compute it right now. So that's a way for you to jump into the middle of your computation and do something, which there is a way to do in TensorFlow as well. But this feels a little more natural to me. Like doing the whole input dict thing in TensorFlow, that's very explicit, which can be nice. But if I'm just exploring data, I often just want the quickest, most intuitive thing. Okay, Let's continue down the baby steps. And this, I'm psyched for this stream tonight. This is going well. It took me 5 minutes to install. I've already done simple computations. Super good, super good. So we added two basic numbers. Look, check out this. Z.eval. Oh, what'd I do? Broke things. Never try to paste directly into your Vim buffer. That's super dangerous. Oh no. Let me copy that. There we go. Alright, never mind. Let's say z.eval. And what are they doing? They're passing in the dictionary. They're just not calling it, oh, whatever. They're not calling it input dict. Uh-oh. I may have crashed. I don't know how I managed to crash my Vim so much. This is sorcery to me. Alright, well, we're going to kill that pane. Wonderful thing about tmux. cd proj Theano. Hey, there we go. How much did I lose? We are going to edit it anyway. We are going to quit. I want to recover. There we go. Let me save that. Oop. Right. So x 1.5, y 2.5, say. We're sending this to beast. And again, that's 4.0 since it's just adding x and y. W, play the same game. But I bet, I'm willing to bet, I can say this is Z. All of America. That's so cool. So that's nice and straightforward. I like that. Right now, I like not having to make a separate session like you do in TensorFlow, but I get why that is a thing, that you might want to have two totally separate graphs that you're, or maybe even have the same graph, and you have it running in two different sessions. So I can see the case for that. Neat. All right, what's next? So that's how you can just eval any particular section. So you don't have to use this function. I wasn't a super big fan of this. This seemed like going around like what I want to do. Whatever .eval is probably what I want. Because inevitably, I'm going to be building up my graph over time, and that's how I'll get around to it. All right, adding two matrices. So instead of saying dscalar, hey, it's a D matrix. So really it's tensor.datatype matrix tensor.datatype scalar. I'm going to use capitals for my matrices because I think that's what makes sense. And I'll even use a capital X. Let's do that. That was possibly more work than it should have been. There we go. All right, now we got a couple of matrices. Z equals X plus Y. Oh, Z.eval. What is a good way to specify my matrix? X, and I'll say numpy dot. Oh, I didn't actually import numpy. Import numpy is np. Woo! Numpy dot, what, zeros, ones, I? Numpy dot random. I like numpy dot random. Of course, then we're not actually going to know. Hang on. Numpy dot random dot rand int. I never remember how to use this. That should be one of my taglines. I don't remember how to use this. Let me look it up again. Right. You sort of put your alphabet size and how big it is and the dimensions of it. So numpy.random.randint 2, 2, 2. Is that what I want? An integer is required. Can I say shape? No. So I did not do that correctly. Size. One of these days, man. One day I'll remember. There we go. 2, I just want, you know what? Well, let's make it 10. So numbers 0 through 9, the digits, size equals 2 comma 2. And there we go. That'll be XX and YY. And you're wondering, why am I not just specifying that in my z.eval? Because I want to see what they actually are first to verify that it's working correctly. So before I hit enter here and just check it out in NumPy, let's do a quick spot check and check it out ourselves. 0 and 9. Okay, that's going to be a 9. 2 and 3, that's going to be a 5. 8 and 1, that's going to be a 9. 1 and 5, that's going to be a 6. You got that? 9, 5, 9, 6. 9, 5, 9, 6. Okay. 9, 5, 9, 6, and did not finish the dictionary. Z is not defined. That's a good point. I never clicked that. Huzzah! 9596. It's correct. It's the same thing. These are floats, which is interesting that it can sort of automatically converts into floats. There's probably a way to... There's got to be a way to... That's something I must have missed here. D-type string corresponding to NumPy D-type in 64. Oh, that's a parameter? Maybe they'll show me how to do that in the later in this. Oh, hey, maybe it's right here. What do you know? I was hoping it would have inherited directly from the NumPy array, but I guess it's trying to be general and let you do what you want, which I also appreciate. There are times when that will bite me, but that's okay. You, the user, not the system architect, have to choose whether the program will use 32 or 64-bit integers. If you don't need 64-bit integers, just use 32. If you're using not much data, it doesn't matter. If you're using a ton of data, you can store a lot more things with 32-bit integers. And your computations will probably be faster. Depending. That's getting really specific. All right. But you have complex scalars, all kinds of... Maybe that's not what I means. Oh, this is for, I see. W is a short, I is an int, L is a long. For 2 bytes, 4 bytes, 8 bytes. Doubles, complexes, all kinds of good stuff. Oh, I guess it does. D does mean double. I was right all along. So if I had said I vector, or I matrix, let's redo it with I matrix. You know what? I don't have to guess. We can just try. Not a double, an integer matrix, of course. And now we get some bad inputs. Bad input argument to Theano function at index. Tensor type, whatever. Matrix cannot store a value of D type in 64 without risking loss. If you do not mind this loss, you can 1. Explicitly cast your data in 32. Alright, you know what? Let me try a long matrix then. There we go. Okay. So NumPy is sort of defaulting to the 64-bit longs. Theano is like warning me in a very serious way, saying, "Hey, be careful, or you're going to lose precision." So my solution was, okay, I'll just use the 64-bit longs. If you're using a lot of data, be careful with that. Switch back to the 32-bit and make sure you put in 32-bit. Because my D type here is int 64. If I said the D type was int 32, that also is signed arithmetic, so be careful with that. Now, whoa, doesn't like that? I can't say D type when I do rand int, really? That's surprising. Oh, well, I'm saying rand int. Well, still. How do I assert size? That's interesting. That I can't get a specific data type of integers. Sorry that I have to like understand random every time I look at it. Is there a rand? I guess there's randf. Alright, well, alternately, you can say numpy.array of this thing, comma d type equals int32. I'm pretty sure you can do that. Yes. Let's just, for giggles, try this. Or as my chemistry teacher used to say, for funsies. Yeah, int type 32 bits. We're taking up 32 bits. Half as much space. Look at that. Amazing. Also, we have different... Note that we have a different array than we had before. But we're using these long matrices. It should yell at us again. Yeah. In its case, it'd be like casting up, and we should say, who cares? But now we're redefining it with the I matrix, the 4-byte value, and now that we're passing in int32s, everything should be hunky-dory. Look at that, magic. Look at that high-tech sorcery right there. All right. What's next? We've added scalars, we have added matrices. We are so good at this. Exercise, ho ho. Import Theano, theano.tensor.vector. So now it's like a one-dimensional matrix. And we're saying out equals a plus a to the 10th power, which I am betting means do an element-wise multiplication 10 times. Let's do that. Let's do vector manipulation, vector computation. That sounds better. V equals t dot d vector. Yeah. V. Yeah, let's do that. A vector is really just a matrix. It's either a 1 by n matrix or it's an n by 1 matrix. So I'm of the opinion that they're the same thing. I find it interesting that they call it out differently. There are reasons to do that, but so it goes. They call theirs A and B. I guess there's nothing wrong with that. Note, you could name the symbolic. You could have the symbolic name be different from the name over here, but I think that's a terrible, terrible idea and will only confuse you. On the other hand, if you want to maintain your job security and not have anyone else learn, then go right ahead and do that. And then no one can understand. All right, so we're gonna have two vectors, A and B. No, we don't have to find a length. They're vectors. Python's gonna figure that out for us. What does it want to do? We want out. That's getting too complicated. Out equals A plus B. Let's just do something simple right now. I want A to equal numpy.array, numpy.a range 10. Now, AA, BB, numpy.a range, 10, 20. Yes, I'm not crazy. Okay. I always forget how the A range works, if it's inclusive or not, but I ought to remember that. So let's say out.eval, and here we're passing in the dictionary. So I guess this is where the function business is actually kind of nice. I sort of specify ahead of time saying, hey, this is going to be expecting the X value and the Y value. So you can just call G of whatever. Whereas if I'm using eval, I have to specify the whole freaking dictionary. So if it's something I'm going to be using all the time, yeah, I should probably make a function to do that. Save myself the trouble. This is an X, this is A. So I don't have to do B, 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 B. Out is not defined. No, it is now. A is not defined. That's really what I get for not. There's like me typing it in the code. There's me actually sending it to the Python session with his just specifying the graph, and then I have to evaluate it. One of these days, man. One of these days. So yes, as expected, things are going up by 2 because this goes up by 1 each time and this goes up by 1 each time. So really, their sum should increment by 2 each time. up to 28. Boom. And starting at 10. Boom. What did they actually want, though? They said a squared plus b squared plus 2 times a times b, which is a sort of a provocative statement, which that's really saying a plus b squared. I'm going to do that because I feel like being lazy. But let's just make a new thing here. A plus b squared. Let's see how that works. And I'm going to do that, which should not take particularly long. And then we're going to do out 3 equals a squared plus b squared plus 2 times a times b. And then you will see these are the same thing. Look at that. Not 4. No. Again, that's all we've done. I didn't actually bother computing this function. I didn't care to do that. They're compiling it as an actual function. I wonder if compiling... Did I skip important things to read? Compiling as a function might save a lot of redoing time. Let's learn about that. Compiled into C code. Eval will be slow the first time you call it on a variable. You use to call function to compile the expression behind the scenes. Subsequent calls to eval on the same variable will be fast because the variable caches the compiled function. Okay, so using eval isn't the worst thing is not the worst thing in the universe. Yes. Notice that first time it took a little bit of time. You might not have noticed. Let me just rename something here. Let's do that. Let's do time. So that was 173 milliseconds. That's not right. All right. A5 equals, let me just say, a cubed plus b cubed, just to make something new. 5. And then let's time creating this new thing the first time. Yeah, that took half a second, which would be way too freaking long. You don't want to wait that long, man. And then you say, you know what? Let's do it again. Now it's 229 microseconds. Look how much faster that was. This is 1,000 times faster because we didn't have to compile it again. And it's taking, typically, using time it, which is a wonderful thing, even faster. That's interesting. I didn't expect a 4x speed up doing that. That's weird. Why is time it so much faster? That's really strange. Time is saying it's taking 243. Time it, where it just does it in a bunch of loops, it says, yeah, you know, that's 63 microseconds. I wonder if it's because this is taking the best of 3 and it's kind of a wide variation in how long it takes. Like here, there's one that's 214. That's weird. And that's just the distribution over 10,000. That might be interesting to explore. Why is the time variation so much? Huh, cool. Okay, but yes, I was a little concerned that using eval in that fashion was going to burn me. All right. We added our matrices. We've done that. Let's look at their solution just for giggles. They're using Python 2. From future import print function. This works in Python 3 too. It's so good. Oh, I love America. Yes, they just type this in exactly, and then they put F, and they get their answer out, which is a plus b squared. Oh, but they're vectors. Did I do that right? Yeah. They're vectors. Doing element-wise arithmetic. No big deal. No big deal, buddy. All right, you know what? That's baby steps. We still have more time. We can do more. This has never happened before. All right, let's close the baby steps. That was admittedly very simple. Let's do more examples. and familiarizing yourself more systematically with Theano's fundamental objects and operations by browsing this section of the library. Basic tensor functionality. As in, what the heck are tensors? I explained last time, tensors are just multi-dimensional arrays for the purposes of computing. There's a lot of math that goes into understanding them, and like very similar to, and yet in some ways probably distinct from matrices. We're not going to worry about that. That's not the purpose of this broadcast. There's a lot of things on that. I don't want to look at that right now. Logistic function. Bit more elaborate than adding two numbers together. Well, sure. Suppose you want to compute something on this logistic curve, which follows this formula. 1 over 1 plus e to the negative x. So this is a function that starts off at a half, when you put in an x of 0, of course, because then it's 1 over 1 plus 1, which is 2. And quickly gets close to 1, but never quite gets there, because this never quite reaches 0. And similarly, down here, never quite reaches negative 1. Or, sorry, not negative 1. Is that right? Yeah, never quite reaches infinity. Like all numbers, it never quite reaches infinity. You want to compute the function element-wise on matrices of doubles. So you've got a big matrix of things and you want to compute it on all of them. Let's do that. I'm not going to copy and paste this because this is pretty simple. I understand this. I am going to note, however, they're using d.matrix, and they have their own, or not t.d matrix for double, and they have their own exponentiation function. Because this is a function within Theano, if I said numpy whatever, their library would have to pass it back out to numpy, do the computation, and pass it back in. By using their built-in one, it's probably a little quicker. So, let me take a pause here to swallow and breathe. Okay. Where are we? Yes, we are going to... So we're just going to compute this function on a matrix. That's all we're going to do. Matrix element-wise computation of logistic function. There we go. So I want my input to be t.d matrix. Call that x. I've got some logistic function, which I want to be 1 divided by 1 plus t.exp of x. Right? Let's double check. Negative x. This is why it's good to check. Because it's super easy to forget everything. Everything you ever learned. If it's not in your bash history, it's gone. I should put that on a t-shirt. I'm only the sum of my bash history. And they are making an actual function out of this. We'll call it logi. Yeah, we'll call it logistic. Function. We are going to pass in x is the name of my thing. And I'm pulling out L. That's right? Yeah. Logistic, okay. And then we can just call logistic. God, that is way too long. I'm sorry. I'm calling it L. Numpy.array. I don't know. 2, 1, 4, -3. We'll just see what happens. These are all valid numbers. That should be fine. One more. Boom, look at those values. Are those right? Let's find out. Is there a numpy.logistic? Maybe? There's numpy.log too, but that's not the same thing. Let's compute what they have. 0, 1, -1, -2. 0, 1, -1, -2. I had almost the same thing. 0.5, 0.73, 0.26, 0.11. That's my hash. 0.5, 0.73, 0.26, 0.11. I find it's much easier for me to remember sequences of numbers if I say them. That's just me though. Like if I need to remember like a phone number or something stupid temporarily, I can write it down, but if I don't have a pencil handy, I just have to repeat it once, and then when I'm remembering it, I'm just literally repeating that phrase back. One of those things. All right, what do we got? It's performed element-wise because all of its operations are themselves element-wise operations. It is also the case that, yes, this is a cute identity. I'm not going to prove this to you. Hyperbolic, like hyperbolic sine, cosine, tangent, they're all very closely related to e to the x. You can write down really cool identities. At one point, I had like a cool philosophical view of like taking derivatives involving e to the x and how it was very similar to doing it with sine. But that's a topic for another day, or probably never. Probably never. You put in more than one thing at the same time. I love how thing is capitalized. It's a thing. That makes my day. At the same time. Theano supports functions with multiple outputs. Oh, well, yeah, that's a Python thing. That's nice. We can compute the element-wise difference, absolute difference, and squared difference between two matrices A and B at the same time. Absolute difference and the difference squared. All right, let's do that. Multiple outputs. Yeah, we're using A and B again. That's fine. Oh, I can specify multiple matrices at once. So this is a matrix, two matrices of doubles. So if they're the same data type, especially, that's convenient. T dot matrices all right, and of course we're taking the difference. Diff equals A minus B. Abs diff equals. Is there a T dot abs? They're just using abs. Interesting. That's way too many things. There is a T dot abs something. What does this do? Tensor variable overloads the tensor variable abs operator, so this function is called when you type abs A. Oh, so if I just type abs, that just calls. I imagine when you type absolute of something, it just calls whatever the dunder method is of that class. So that's why it's reasonably fast. And so we're not actually doing high-level Python here. Diff. Diff squared equals. I'm gonna be a rebel. Woo! Yeah, not the 21. I could use abs diff, or I can just use diff. Doesn't matter. What do they call it? They make a function. Let's make a function. I like functions. Our input is A comma B. Our output is abs diff square. Right? And diff. And how. Name diff is not defined. In fact, none of this stuff is defined. There we go. That takes a little while to... Oh, because it compiles the function. Right. I wonder is my... Where am I? Huh. I wonder where it compiles those things. Or if it's all in memory. That'd be something to look up later, maybe. Okay. We're passing in these two arrays. Yeah, D matrices produces as many outputs as you provide. It's a shortcut for allocating symbolic variables, and we often use a tutorial. D matrices is going to be wonderful, I can tell already. Or D integers, maybe? Or D scalars, I guess. Yes. So what do we do? What do we have here? We have two arrays. Notice the syntax highlighting. Here and here. This is an array of all ones. And this is an array that's 0, 1, 2, 3. Just for giggles, I'm going to specify these a different way. 2, 2. Can I do that? Yes, I can. And this one is going to be numpy.arange 4.reshape It's my selection. Bam, look at that. Okay. So the numpy.ones, this just says make an array of all ones of the shape 2, 2. Numpy.arange says do 0, 1, 2, 3, and then I reshape it to be 2, 2. I don't like that reshape. You do it in this 2, whatever. You have actual different arguments for the different element sizes instead of just one list, but that's the way it is. If you have your arguments already in a list and you wanted to pass them in as a variable, you would do, suppose this is my element list, arange 4, that reshape you do. So normally, like, I would want to do that. Oh, that works too. I stand corrected. I thought this was going to yell at me, but that is not the case. That's good. Because if I have this, it's fine. And you can also unpack the variable. That's also fine. Fantastic. That's good. That makes my day. That's absolutely great. We might even finish early today, depending how we go with this. Setting default value for an argument. Hey, let me guess. Yes, when you specify your function. Oh, you say param. I have to import param now? Alright, let me do that. Param. Paramos. So, let me go back up here. Param y, comma, default equals 1. Let's do that. F of 0, 1. F of 0, comma 2. Boom. If I say F question mark, what do I get? Type of function returned by Theano. Now I'm just kind of curious, like, what can I get out of a function that I have created? Pickle aliased memory strategy. I just want to know what this is. That's just fun. The fact that there's a whole module called pickle is hilarious to begin with. All right. I wanted to see. Oh, F dot name. Nothing. I wanted to see, like, if it would tell me what the definition of F was. But I guess that's really, like, all it has is inputs and outputs. It's really the output that is the interesting thing. Not outputs. Out, element-wise, add, comma, no in place, dot 0, comma, false. So that's like literally explaining what Z is. Z, element-wise, add, comma, no in place, dot 0. Yeah. I don't suppose it can... If I look at Z, which is where I've defined the operation x plus y, does it tell me... What is auto name? Can you string object from the given? Can I just do that? I don't know why that's the name, but whatever. Choose clone, conj, copy, eval, get parents. All right. Well, that would have been interesting if I could have pulled out like the source line that defined it, but I understand why you wouldn't. Why you wouldn't do that? That doesn't actually make sense. What if I print Z? Yeah. String Z. Ah, repr Z. Maybe that's what I want. Interesting. Huh. Well, that's weird. So we can set default values. That's nice. I like having those. This is a little arduous for doing that, but not a big deal. Param class allows you to specify properties of your function parameters with greater detail. Name equals W by name. Oh, so you can have a named parameter as well. W by name equals Y equals, which is, oh, Y and W are different things. Param does not know the names of the local variables Y and W that are passed as arguments. The symbolic variable objects have name attributes set by descalars. See function in the library in more detail. All right, so there's a lot of things going on here. Using shared variables gets a little into using random numbers. Oh, they have their own random number generator. I'm curious how they implement theirs. Did they say? See other implementations, raw random number drawing functionality. So what is the actual algorithm they use to generate the random numbers? That is what I want to know. Honestly, for most like data analysis purposes, you don't need like a cryptographically secure random number generator. Just use whatever. It's probably not a problem. Did they not say here? Alright, well, is what it is, I guess. Friendly random numbers. That's actually kind of cool. Random streams. Let me click back a little bit. Alright. Right now, I'm just like poking around, seeing like, oh, what's this cool thing? What's that cool thing? I think that's a good sign that I should probably take a break and pause for the evening. So I'm super psyched that some people came to watch and were interested, and I'm super stoked that, and nobody uses the word stoked anymore, but that's okay, that people were curious about the workflow. Because I'll be honest, like, I enjoy machine learning, and I enjoy statistics, and I enjoy software, but the workflow is like, I've been accused of being obsessed with workflow. That's why I have that whole website devoted to it. And that's why I have a whole GitHub repo attached to that. So I might, probably like after I'm done having fun with Theano, maybe I will devote a whole session to let me install and explain my workflow. I think I have an old video where I do something like that, but it would be good to do that with a new video, I think, too. All right, but that was our first look at Theano, another machine learning framework. Thank all of you guys for coming out, and we are going to be back here again next week. Until then.